Hello everyone, let's talk about section 3.2 now. 3.2 is on exploring parallel lines, so we're going to spend a little bit more time with our parallel lines and we're going to spend more time with our transversal. So right here I'm going to start off with a little exploration, and this exploration is going to require us to use a tool that's called a protractor to measure some angles. So here's the exploration that we're going to work on, but here's the tool we're going to use. So a protractor is great at measuring the angles, and you can see all of our degree measures listed right up here, with one set of values right here increasing and one set decreasing right there. But these are not actually the most important parts. The critical portions of the protractor are listed down here at the bottom, starting with this hole. This hole right here is not a spot for you to put your pen into, but rather it is a place for the vertex of an angle to live. So that is going to be the turning point for the angle, and you are going to want to set that hole right on that vertex. Then also we have this line that is printed right next to this hole, and that is the line that you are going to want to line your angles side up with. Then you can read your numbers and have an accurate measure. And that's what we're really going for here. We're looking for some very accurate measures. So let's line up our protractor on our first drawing right here. We are interested in the angle KLN. KLN is this large angle right here. I would call it obtuse. So when I set this guy up, I want to once again make sure that this hole is right over the vertex. And then I want to adjust my protractor so the line that is printed on it lines up perfectly with the line on my drawing. So I'm going to have it like this. Now that everything is lined up appropriately, I'm going to follow my last or terminal side right here all the way out. And once again, this is a big angle. So it looks like I have two choices, something close to 30 or something close to 150. I'm going to choose the bigger one because my angle is obtuse. So I'm going to ignore the 30 for right now, and I'm going to travel over here. Now, like I said, it looks like it's a little bit bigger, or right around 150, but it's a little bit smaller, a little bit to the left. And so I would say that my answer is going to be about 148.5. 148.5 degrees is going to be a great answer right there. Let's do the second one. So now our second angle that we have right here is going to be angle RPQ. RPQ is this small angle right here. It's so small that I would call it acute. And so when I line up my protractor, I'm going to make sure the vertex is right in the hole, and then I'm going to adjust the printed line on the protractor to line up with the line that is printed on the page. And then once it is lined up perfectly, now I can trace my third or terminal side right here all the way up. And I am once again presented with two choices, something that's close to 60 or something that's close to 120. My angle, as we'd already talked about, is pretty small. So I'm going to ignore the 120 this time, and I'm going to focus on the 60. Now, is it exactly at 60? No, it is a little bit less. And so what we want to do is we want to make sure that it's a little bit to the left, I should say. And so what we want to do is we want to choose a value that's going to match that as well. As we move to the left, you'll notice that the numbers are actually getting bigger this time. And so our answer is going to be a little bit bigger than 60 degrees. I'm going to say it's going to be 61 degrees. There is your second answer right there. So we had one large or obtuse angle, we had one small acute angle. One time we used the numbers on the outer edge, and one time we used the numbers on the inner edge. Okay, so now that is good warm up right there to get you used to using your tool, but now here's the job that we really need to do. What I have for you is I've drawn two lines on the page already, and I want you to draw your very own transversal. These lines are unique because if you look carefully over here, you'll notice that they are parallel lines. So when you draw your transversal, you can use the straight edge of your protractor and just draw a nice long one. I want you to draw it so it's pretty much as long as the protractor is. And when you do this, what you're going to do is you're going to create some clusters of angles. Now, it would be great to know all of the angle measures in these clusters, so we are going to be exploring each and every one of those, and I'm going to use my protractor to do it. When I set my protractor up on the vertex with the line that it was printed there for me, I can take a look at what my larger angle is and what my smaller angle is pretty much at the same time. My larger angle is going to be following these numbers around the outer edge, and it looks like I'm going to get something that's close to about 124 degrees. 124 degrees. Now, for my acute angle, I want to set up my protractor to be pretty much the exact same location, but this time what I want to do is I want to make sure that I'm looking at those smaller numbers this time. So I'm going to set it up perfectly as this time, and I'm going to be looking at this angle that is going to be coming over here. It's a little bit less than 60 degrees, right between the 60 and the 50. I'm going to say that that's going to be a little bit more than 55. I'm going to call that 56 degrees. Now I have 6 more angles to find, and so if I set up my protractor, this time I'm going to set it up upside down, and I'm going to be looking again, and what I notice is that my angles are in the same spot on my protractor, and that means the angle measures are going to be the exact same. I'm going to end up with another 56 degree angle, and another 124 degree angle, and another 56 degree angle down here, and another 124 degree angle, and another 56 degree angle, and another 124 degree angle. There were so many angles that we had created, and yet the answers or the measures for these angles are all almost identical. And so that's a very interesting thing. When geometric mathematicians were looking at this, they noticed all these patterns and they got really excited about them and they wanted to talk about them. And so they were looking at all of these different kinds of situations, all of these angles that match very, very nicely, and the way that they match between the 2 different clusters, and they were just thinking how amazing that is. The things that we're going to see when we're looking at this picture right here is what we're going to notice is we're going to find all those angles that we had talked about in section 3.1. There are corresponding angles that match. And there are going to be alternate interior angles that match. And there are alternate exterior angles that match. And there's even consecutive interior angles. And these consecutive interior angles, they don't match. They are going to be 56 and they are going to be 124. But the interesting thing about them is that when you add them together, even though they don't match, they add up to a very happy digit for us, 180 degrees. Let's get this information formalized a little bit. So right here, what I have is, we were just talking about transversals, and once again, transversals are lines that do intersect, and they're going to intersect 2 lines, not just 1. And what we were just talking about is some amazing characteristics that we just noticed. We found that corresponding angles, when you create these transversals on parallel lines, corresponding angles are all of a sudden now congruent. That's amazing. That's a new fact and a new great fact to use. Alternate interior angles also matched, and that means they're also congruent. Alternate exterior angles also matched, and they're also congruent. Now, the consecutive interiors, they were not matching. That is the set that did not match at all, but they have a different characteristic, which is fantastic and wonderful, and that characteristic is the fact that they are supplementary. They're equal to 180 degrees when they're added together. This is so great. And if you take a look at our picture right here, this is really going to drive it home. Basically, when you're looking at this picture and you see that you've got your parallel lines right here with your transversal, if they look the same, that's because they are the same. Little acute angles, no matter where they live, are all going to have the same angle measure, while your larger obtuse angles are also going to be matching. Doesn't matter where they live, they will match with one another. So that's fantastic news. Let's look closely at our first example problem. For our first example problem, I want you to take a look at how little information I'm going to give you. I'm going to give you your 2 parallel lines and your transversal, and I'm going to give you exactly 1 angle measure. That is this baby 125 right there. And now what I'm requesting from you is I want you to tell me 7 other angle measures. That's a very little for me to give and a lot for you to give. And so that's an interesting little conundrum or dichotomy there. It doesn't matter though, and it's not that difficult because we have all of this great information. If I find an angle that corresponds with 125, like 7 down here, it will have the same measure. If I find an angle that is alternate interior with 125, like 5 right here, it will also have the same measure. Even if I find vertical angles, I will find that they are going to have the same exact angle measure. So I can take my one single 125 and turn it into 4 of them. So now I've got quite a bit of my work done. Now I also have some missing values above and below on the top in both of the clusters right here. And so I'd like to get some values for those. Now, they're not 125. You can plainly see that these are acute angles, so we do not want to use such a large number again. So what we are going to do instead is we're going to have to figure out what the other number is going to be. The way that we're going to find that is by realizing that these two angles right here, right next to each other, are a linear pair. They are supplementary, which means that if you take that 125 and you add it with our mystery angle, you will get 180. Now what you can do is you can solve for our mystery angle by subtracting 125 from both sides. And when you do that, you will get a very happy little answer, which is 55 degrees. X is equal to 55. That 55 lives in this location right here. Whoops, 55. And all of the other angles that are attached to it. So this angle right here corresponds with number 6, and this is another 55. It is alternate exterior with number 8, so we have another 55 right here. It is vertical with number 4, so we have another 55 right down here. So what we did is we started off with exactly one angle. We did one little bit of subtraction, and now we have 8 angles on our page. That's very quick, but also very easy to do. So I like that question a lot. For our second example problem right here that I want to do with you, I want you to take a look at these guys right here, and we're trying to find out what the value of x is. Now, in order to find the value of x, we're going to need to know about the relationship between these two angles, and so that's going to be an important piece. If I'm looking at these, what I notice is that these angles are on the exterior, and I'm also noticing that they are alternating. One is above the transversal, and the other is below the transversal. These are alternate exterior angles. And because they are alternate exterior angles, we can find out right up here, alternate exterior angles are congruent. That means that these two things that we have chosen right here are going to be equivalent to each other. 113 degrees is equivalent to 3x minus 4 degrees. And now this is going to stop being a geometry problem. We're done with this picture. We've gotten everything that we can possibly get from it. And now we are going to just move on to our algebra skills. We are going to add 4 to both sides, and that is going to bring this up to 117 is equal to 3x. And then we're going to divide by 3 on both sides, and 117 divided by 3 is going to give us an x value of 39. I like questions like this too because of that transition. We start off with a geometry idea, we use the concepts that we learned in class, and once we're done with those concepts that we learned in class, we are able to solve using our algebra skills. Here is a you try it problem that is very similar. Pause the video now and try this one on your own, and then I'll share my answer with you. The two angles that are listed here in our drawing are not going to be as easy. This angle and this angle are alternating on either side of the transversal, but we have one exterior angle and one interior angle. So we are not in great agreement right now. They're not alternate interior, they're not alternate exterior, they're not corresponding, and they're not consecutive in any way. So we have a bad match. What we can do, however, though, is we can help out our bad match, and we can move a couple of things. This x plus 5, it is not the only place that it lives. X plus 5 also lives in a bunch of other places. All of these angles that I have marked right here are also going to be equivalent in size. So I can call this angle right here x plus 5 as well. Now, this is going to be a great place for us to be because this new location for x plus 5 and 3x minus 7, they're right next door. And they're lying together next door on this nice straight line. They are forming a linear pair. These two angles, if added together, are going to give us 180. Last time we did an example problem, we set the two angles equal to each other. This time we are going to add the two angles together, and we're going to set them equal to 180. So not everything is about equivalency. This time it is about adding. Once you've done that, once you've made that move right there, we've used corresponding angles and we've used linear pair. Now we are down to our algebra problem. And so we're going to work on this guy. Let's combine some like terms. I've got a couple of x's that I can combine together. I've also got a couple of constant terms that I'm going to combine together as well. I'm not changing signs right here. I'm just combining the terms or simplifying my equation. Then what I can do is I can now use opposite operations to bring my 2 over to the other side. And this problem does end up with a decimal answer. Whoops, I forgot my 2. And that decimal answer is just fine. It is okay to have decimal answers. Decimals show up in a world where gas costs $3.09. And that is just fine. So our answer is going to be 45.5. There are much worse decimals in the world, but that is the one for us. There are some more examples on the back of this sheet, but we are not going to do those today. We will save those for a different day. Your next job is to work on your 3-2 practice homework assignment.